If lion steak appeared in your grocery store tomorrow, the shocking part wouldn't be the taste. It would be the price tag and the mountain of food that had to disappear before that steak could exist. We blame danger, poison, or disgust. But those are only pieces. The real answer is hidden inside a brutal law of nature that shaped every human menu on Earth. And once you see what it takes to produce one predator, a cow will never look expensive again. Before we solve it, the question needs one correction. People do eat predators. Bear meat is eaten in parts of North America, Northern Europe, and Asia. Alligator and crocodile appear on restaurant menus. People eat shark, squid, and octopus. And tuna, the fish inside millions of sandwiches and sushi rolls, is itself a fast, muscular predator. Even familiar farm animals do not fit into a clean prey versus predator box. Pigs and chickens are omnivores. A chicken will happily eat insects, lizards, and even small mice, so predator meat is not automatically poison. A properly handled piece of meat does not know whether the animal once chased another animal. The real mystery is narrower and more interesting. Why do humans sometimes eat predators, but almost never make large predators a staple food? Why did we build entire economies around cows and chickens, while wolves became competitors and lions became symbols? The answer begins below the predator and everything it had to eat before it became large enough for us to eat. Every animal body is built from energy. Plants capture energy. Herbivores eat the plants. Predators eat the herbivores. But at every step, most of the energy is used before it can become new body tissue. An animal breathes. It walks. It keeps warm. It digests food. It escapes danger. It reproduces. All of that costs energy. Ecologists often introduce this with the 10% rule. Only a small fraction of biological production passes from one trophic level to the next. 10% is not a magic number, and real food webs vary enormously. But the shape of the problem remains the same. There is much less production available at the top than at the bottom. Imagine raising deer for food. Now imagine feeding those deer to wolves for months or years, waiting for the wolves to grow, and only then eating the wolves. You have taken edible animals, passed them through another living body, paid for every heartbeat and every mile it ran, and received only part of that mass back as wolf. This does not mean wolf meat has fewer calories per bite. It means the wolf itself was extraordinarily expensive to create. A farm that sold predator meat would first need another farm producing the predator's food. And if people could already eat that food, the extra step would be a magnificent machine for turning dinner into less dinner. The same arithmetic shaped hunting long before farming existed. A landscape can support many plant eaters, but only a much smaller number of large carnivores. Each predator needs prey, territory, and time. Large carnivores may travel across enormous ranges to find enough food. That makes them terrible targets for anyone trying to feed a community. If a group hunts one deer, other deer remain. If it repeatedly kills the few breeding predators in a region, the local population can disappear quickly. And finding the predator is only the beginning. Humans usually want the greatest return for the least danger. A large herbivore can be extremely dangerous, but it does not normally hunt the hunter back. A wounded lion, tiger, or bear can. A modern review of hundreds of thousands of kills by subsistence hunters found a strong preference for large herbivores, especially hoofed mammals. That is not mysterious. They offer large packages of meat without requiring humans to search the almost empty top of the ecological pyramid. Our ancestors did not need equations to understand this. They only needed to notice which hunt filled the camp and which hunt removed one of the hunters. But humans eventually domesticated wolves. Does that prove we could have farmed predators if we wanted to? Not quite. The animal that became the dog offered something more valuable than its body. It could detect danger, follow scent, guard a camp, help locate prey, and consume scraps humans did not want. A living canid could help humans acquire food again and again. A dead one provided meat once. That is a completely different bargain from livestock. Cattle, sheep, and goats can turn grasses, leaves, and other plant material into food humans can use. Chickens and pigs can consume mixed diets and reproduce relatively quickly under human care. A strict meat-eating livestock animal would reverse that advantage. Instead of converting resources people struggle to digest into human food, it would consume animal protein humans could have eaten already. So we did find a place for a predator beside the fire. We simply found that its eyes, nose, and cooperation were worth more than its muscles. The wolf did enter the human food system. It entered as a co-worker. This is where many explanations become suspiciously confident. They claim predators taste bad because their muscles are full of stress hormones, lactic acid, or a lifetime of running. That is not a universal law. Flavor depends on the species, age, diet, fat, sex, season, handling, and cooking. Some people describe certain carnivore meats as strong or gamey. Others compare mountain lion to pork and say properly prepared bear is excellent. The category predator includes animals as different as tuna, alligator, lion, and octopus. There is no single predator flavor connecting all of them. Taste may reinforce a food tradition after it exists. It cannot explain the global pattern by itself. If a rare animal is dangerous to obtain and costly to support, few people gain experience preparing it. Without a reliable supply, no cuisine develops methods that make it familiar, desirable, and safe. Sometimes food tastes normal because generations learned how to cook it, and sometimes strange meat tastes strange because almost nobody had a reason to practice. Predator meat is not automatically toxic, but some risks are very real. Wild carnivores and omnivores can carry trichinella, a parasitic worm whose larvae can live inside muscle. Humans can become infected by eating raw or undercooked meat from animals including bear, wild boar, wildcat, fox, wolf, seal, and walrus. The parasite is one reason bear meat requires careful handling and thorough cooking. It is a specific biological risk, not proof that every predator is filled with mysterious poison. The second risk is easier to see in the ocean. Certain persistent contaminants become more concentrated as one animal eats many others. Large predatory fish, such as shark and swordfish, can contain high levels of mercury. This is why food agencies give specific consumption advice, especially for pregnant people and young children. But biomagnification is not a time machine carrying every dangerous thing a predator's prey ever touched. It applies to particular substances that persist and accumulate. Then there are dangerous organs. The liver of a polar bear can contain enough vitamin A to cause severe poisoning. That fact is real, but it does not make an ordinary piece of every predator poisonous, and it should not be reduced to a cartoon in which each step of the food chain multiplies every chemical. These risks matter. They help explain why some predator meals require caution, but they are supporting characters in this story. The food pyramid had already made large predators rare and inefficient long before modern mercury pollution entered the ocean. Once humans stopped treating large predators as normal food, culture pushed them even farther from the plate. Lions became kings, eagles became empires, wolves became ancestors, monsters and guardians, bears became spirits, rivals, and symbols of strength. Some religions prohibited animals that hunt with fangs or talons. Other cultures did eat certain predators under specific conditions. There was never one universal human rule, but a broad pattern makes sense. Herbivores were food. Large carnivores were competitors for that food. They watched the same herds, approached the same carcasses, and sometimes threatened the same people. An animal you fear, fight, admire, or recruit as a partner occupies a different mental category from an animal managed as livestock. Culture did not need to invent the ecological arithmetic. It gave that arithmetic stories, taboos, and symbols. Over generations, rare and impractical to eat could become unclean, sacred, disgusting, or simply not food. The boundary feels natural today because culture is very good at hiding the history that created it. So why do humans never eat predators? We do. We just rarely build food systems around large ones. Not because every predator is poisonous, not because evolution placed a warning label inside your brain, and not because a wolf steak contains no nutrition. The answer is simpler. Nature produces many plants, fewer plant eaters, and fewer large hunters above them. By the time humans arrive at the top, most of the potential food has already been spent keeping the predator alive. The remaining animal is rare, difficult to replace, dangerous to capture, and expensive to raise. Some species add parasites, contaminants, or dangerous organs. Then culture turns a practical pattern into a permanent rule. A cow converts resources into a continuing supply of food. A dog helps us find and protect that supply. A lion competes with us for it. That is why the lion became a king instead of cattle. Predators stayed off the menu because they were too valuable alive, too costly dead, and because the cheapest lion steak is all the meat the lion never got to eat.